For example 1, we're going to use rules of exponents, but now with rational exponents. Like for this first part here, we have x to the 1/2 times x to the 1/4. So the good news is that all the rules that we already know for exponents apply to rational exponents as well. So here, you would simply add the exponents. So that would be x to the 1/2 plus 1/4. And so we'll need a common denominator to do so. So I'll write 1/2 as 2/4 plus 1/4. So we have x to the 3/4 power. So here we've combined these two just by using our familiar property of adding exponents. And if you'd like, you could write this as the 4th root of x cubed. So you could stop either here or here, but we combined by adding exponents. And our other big rule was, okay, if we have y to the 1/3 and we raise that to the -9th, here we're actually going to multiply the two exponents together. So that's going to be y to the, let's see, 1/3 times -9 is -9/3, which simplifies to y to the -3. And if we have a negative exponent, I'm going to always write them so they are positive by placing this in the denominator. So y to the 1/3 all to the -9th power reduces to 1 over y cubed. So like I said, all of the rules that we already know for exponents apply to fraction exponents as well, and we'll try that in maybe a couple more complicated problems. So for example 2, here we have -4 times x to the 1/2 times y to the 5/4, and this whole thing is squared. So we could just write this expression down twice and combine some like terms, but I'm going to take the approach of breaking this up into pieces and squaring each part of it. So we'll have to deal with the constants differently with the variables, but all the rules will still apply where if I have -4 and I square it, it's going to give me positive 16. Now if we go back over here, we kind of ran into this in the previous problem, but I'm going to multiply the 1/2 and the 2 over 1. The product of those two things is actually just 1, so you get x to the 1st. So that came from 1/2 times 2, or 1/2 times 2 over 1, if you'd like. And then for the last piece, y, that's going to be the product again of 5/4 and 2 over 1. So if the numbers become tricky, you can like do some work off to the side. I mean, this one isn't very difficult, but 5/4 times 2 over 1. The result of that product is going to be my exponent on y. So here, let's see. Right, 4 goes in here twice and in here once, giving me 5/2. So that's the exponent on y, 5 over 2. And it's fine to leave your answer like this, but again, you could write 16x, I won't write the first exponent, and note that this is the square root of y to the 5th power. And this is how I would simplify a more complicated expression using our familiar rules with exponents. All right, getting trickier here. Let's see, example 3. Here we have a fraction with different exponents inside it and different variables, all to the 1/3 power. Maybe I'll place a exponent of 1. Maybe note that this is really -8 to the 1st power here if you want to just be a little bit more explicit. But just like in the previous example, this 1/3 gets multiplied to each exponent that appears in this expression. However, when we simplified these, it was kind of good to actually reduce what happens here first and then apply the exponent to it second. That way you're going to have fewer terms to deal with. So what I'm going to do is reduce inside the parentheses. So I have that -8 to the 1st. I can't really combine that with anything. I'm going to leave it as -8 to the 1st. But here, with the x's, I have x to the 5th divided by x to the -1. The rule that we had for that was, if we're dividing, we subtract the exponents, so you get x to the 6th. So I'm going to place that here. And then let's see, we have y to the 1st divided by y to the 10th. So again, for that piece, thinking about it separately, that's y to the first minus 10, which is y to the negative 9. And that negative 9 means I can place that in the denominator. So I'll do this. And this is all to the 1/3. All right, so now that it's a little bit simpler inside the parentheses, I have fewer terms to apply the 1/3 power to. I think it's going to make it a little bit easier to think about. So if I multiply the exponents, I'll have a third, I'll have 6 times a third, and I'll have 9 times a third. This is going to be great because I'm dividing these numbers by 3. So I'll have a 2 here and a 3 here. Unfortunately, I'm going to have to write this as 1/3, but hopefully it'll simplify nicely for us. I have negative 8 to the 1/3. I have x squared, and I have y cubed. So I guess the last thing to deal with here is, well, what is negative 8 to the 1/3 power? And as we've seen, this is what we call the cube root of negative 8. What number that when I cube it gives me negative 8 back? And the answer is negative 2. You can even check. Negative 2 cubed would be negative 8. So I'm going to place that in my answer as I have negative 2, I have x squared, and I'm divided by y cubed. And that's my final answer. And for the final example here, just something that will use maybe some distributive properties to be a little bit careful here. Here I'm multiplying, and in both of my expressions, I'm seeing that, okay, in this very first one, I'm separated by a plus sign. Here, there's this minus sign here, so I have to be careful when multiplying these expressions together. So we'll focus on this one first. But you'll approach it the same way, where this gets multiplied to both terms inside the parentheses. So I'm going to start there. I'm simply just going to multiply these things together, and maybe I can simplify it a little bit as we go. So I get 2 times the square root of x times 4 times the square root of x, just multiplying it in. And then I get plus 2 times the square root of x times x to the 3/4. And technically, I've done it. I've multiplied that 2 square root of x into the parentheses. But I'm guessing we can start combining some things. I mean, there's a lot of ways to approach this. I think what I'm going to do is place everything so it has an exponent that's a fraction. So this is 2, I have x to the 1/2, times 4 times x to the 1/2. Then I have plus 2, x to the 1/2 times x to the 3/4. This way, okay, I see that I have similar things that can be combined. I have x's to different powers. I think I can just add the exponents together. So I'll take this 2 and I'll multiply it to the 4. It'll give me 8. But then I'll have x to the 1/2 times x to the 1/2. And this piece over here, it's actually set up pretty nicely for us. So I get 2 times 4 is 8. I have x to the 1/2 times x to the 1/2. And again, over here I have 2 x to the... I know that since I have to add the exponents, I'm going to write 1/2 as 2/4 x to the 3/4. So to combine all this, I will add the exponents, 1/2 plus 1/2. And then the second one, I am going to have 2 x to the 2/4 plus 3/4. And when I add all this together, that's 8x to the first plus 2x to the 5/4. And you can leave your answer just as this. You could also just write 8 to the power of x, and if you'd like, you could write this as the 4th root of x to the 5th. I forgot to put the 2 in front of it, but both of these answers are completely acceptable. The idea is to multiply using properties that we already know, and then just take it one step further and use properties of exponents to combine any possible like terms. So for the second piece, which is squaring out this term here, I'm going to write this expression down twice because I think I'm going to have to FOIL to multiply this thing out. So let's try that out. I have the square root of x plus 1 minus 1 times the square root of x plus 1 minus 1. It doesn't matter how messy the expressions get, we can still use our familiar property of distributing to multiply this together. That means this gets multiplied to those two terms, and then I just repeat this process for the -1. I'm going to write out all of those things. The first was the square root of x plus 1 times the square root of x plus 1. Then I get minus the square root of x plus 1. Distributing the -1, I get another minus the square root of x plus 1, and -1 times -1 is positive 1. So again, here I've done it. I've multiplied these two things together, but I'm seeing that some stuff can be combined. So I'll leave this part alone, come back to it in a second, maybe that can be simplified. But I have two of these things. I'm going to condense this into, I have two x plus 1 under the square roots and a plus 1 at the end. And it's looking like we're pretty good. I mean, we've taken this pretty far, but just like in the previous example, there's something that we can do with this expression here. Like, if you'll note, back in the first part of this example, we had the square root of x times the square root of x. We switched it to the 1/2 exponents, and when we added them together, it just gave us 1. If you notice, you could actually just start here and immediately end up with x. If you multiply a square root of x by a square root of x, the square root cancels, it just gives you x, the thing under the square root. I'm going to use that idea here. The square root of x plus 1 times the square root of x plus 1, it's just x plus 1. They both have an exponent of 1/2. A half plus a half is 1, and I'll leave it as that. Copy down the rest of the problem. And technically you don't need the parentheses on that first thing. You could just put x plus 1 minus 2 the square root of x plus 1 plus 1. And written that way, I actually see, oh, well, I have a 1 and a 1 that I can combine, and I cannot take this any further. I mean, this is as far as I can go as my simplified answer. So again, we're starting with something familiar, but here I'm just using some properties of exponents to combine all possible like terms.